Hello everyone, and welcome to the lecture on binary search. So, we're going to go over binary search. In the next lecture, we'll do an implementation of binary search, and we'll also discuss the iterative and recursive versions of binary search. So, in the last lecture, we talked about implementing sequential search and how we had different implementations for ordering or ordered lists and unordered lists. So we can actually take greater advantage of the ordered list. So if we know a list is already ordered, instead of searching the list in sequence, we can do a binary search, which will start by examining the middle item. So, a binary search will start by examining that middle item. If that item is the one we are searching for, we're done. If the item we're searching for is greater than that middle item, we know that the entire lower half of that list, as well as the middle item, can then just be eliminated from further consideration. So we can already drop that off of our overall search. Then the item, if it's in the list, must be in the upper half. So we just keep repeating that process with the upper half. Start at the middle item of that upper half, compare it against what we're looking for, and again, we either find it or split the list in half, therefore eliminating another large part of our possible search space. For example, let's look at the previous array we looked at a couple lectures ago and search for 54 again. Instead of starting at the beginning here at 17, like a sequential search, what we're going to do is start right in the middle. Then, we'll check this number against the target value, which is 54. Since this number is less than 54, it's 44, we know that everything in the lower half of the list can now just be discarded. Then, using the upper half of the list, we just continue on. So we jump to the middle here, which is 65. Since it's greater than, we can start and keep doing this, basically splitting that list in half, which is why it's called binary search, and continually go until we find the actual element that we're looking for. So, binary search uses divide and conquer. We divide the problem into smaller pieces, solve the smaller pieces in some way, and then reassemble the whole problem to get the result. So you'll hear that term divide and conquer quite a bit when you're studying data structures and algorithms. Let's do a binary search analysis. Each comparison eliminates about half of the remaining items from consideration. Then we want to know what is the maximum number of comparisons this algorithm will require to check the entire list. In this case, it depends on the number of comparisons and approximate number of items left. So if you have to make just one comparison, then you have about n over 2 approximate number of items left. With 2, you get n over 4, 3, n over 8, etc., all the way until you get to I comparisons, just a general term. For n items, then you're doing n over 2i, 2 to the power of I, approximate number of items left. Alright, so up next, we'll see how to implement two versions of that binary search, and you can check out the Jupyter Notebook related to this lecture for more information on binary search. Okay, thanks everyone, and I'll see you at the next lecture.